Cabri that I just wanted to show to us before we keep working on the rest of our Cabri constructions today. We're going to spend the first half kind of working on those other constructions, but I want to review this one. So given a triangle, construct a circle which passes through the vertices. Where would we want to start with Cabri here? Yeah, if we were going to do it. Yeah.
Create a triangle.
Right. So we really want to start with a triangle, right? So construct a triangle and then construct, right, a circle. Right, passing through vertices, or wait.
Yeah, but you have to do something to make sure the circle passes through the vertices.
Okay. So what did we do? What did we do? And here's one that somebody submitted to the board. So this is great. Okay, or to the course conference. Well, it's interesting. It's interesting. So how would we start? How would we start? I like this. So start with a triangle. And we'll have to see how this worked. But start with a triangle and then what? What might we say, Emily? Since you were sort of leading this.
Sorry. I created perpendicular bisectors to each side of the triangle.
So if I'm looking at someone's construction, there's kind of a cool tool in Cabri where you can go to Edit and choose Replay Construction. Right? So this is kind of cool. So it tells you sort of in order what somebody did or what you did, right? It's a nice way of sort of sharing how you constructed things and sort of reviewing, okay, how's our process here and how does that relate to the problem, right? So we started with a point, another point. You see we're building a triangle. So far so good, right? And then it looks like the next step was to find a midpoint. We found all three midpoints and then did a perpendicular bisector of a segment and then another segment and then another segment, right?
You can skip the midpoints, right?
Yeah, what do we think?
Yeah.
Probably could have skipped the midpoints, but doesn't detract from the construction, right?
There's also a thing to make a triangle.
There's also a thing to make a triangle. I agree. So here's my question. What's significant here about why perpendicular bisectors, I guess? Why is that going to be helpful in constructing a circle that goes through all 3 points, right? I mean, I agree, yeah, it sounds great, but why? Iona, yeah.
Because on a perpendicular bisector,
Okay.
the point on that perpendicular bisector is going to be equidistant from the endpoints of the segment that are perpendicularly bisects.
Any point on a perpendicular bisector is equidistant from the endpoints of the segment that it bisects, right? Close. Okay. So Iona, so what might be significant then, or explain to me kind of what's happening here.
Well,
this is right,
where
but
they all intersect.
where they all intersect. So they all intersect right here.
Yes. And if you consider that a point on just one of the perpendicular bisectors.
Sure. Let's sort of look at the one on the right here.
It's going to be equidistant from the endpoints of this line segment.
This point must be equidistant from those 2 points, right?
Yes.
Okay.
And then if you take a different perpendicular bisector,
Okay. I'm doing it. Keep going.
it's also going to be equidistant from the endpoints of the line segment it perpendicularly bisects. And you can see, and then you could just use substitution to say orange equals orange, orange equals purple, purple equals purple, orange equals purple.
I like it because they all equal each other. You could use the transitive property or substitution, right, to say that therefore all 3 of these segments are equal.
And then radii.
So they're radii of a circle. Let's see if that was the next construction.
You really only need 2 perpendicular bisectors to do that.
Interesting. Yeah, quite possibly you'd only need 2, right? Because with 2, that's sort of what we used right here,
Yeah.
right? We only used 2, right? Like 1 and 2, although 3 also works.
It's still working, but it's just we didn't see it.
Right. And then, so then we should end up with a circle. Interesting. Okay. So did anybody notice that last step?
Point.
So we picked a point right there, and then made a circle through that point.
Why would you choose a random point?
I don't know. I wonder.
Like, what if that point was like?
It says point on object line, circle through the point, the last constructed object. So do we think this is going to work? Maybe?
No. I think it's like random.
So it's close. So we're really close. So what needs to be different here? We've got our perpendicular bisectors. We found that point. Iona explained why they're all equal, why that point must be equidistant. What do I need to really make this construction stick? What do we think? Rowan?
Well, like you create a circle and like point on the, or like click on the points there, so then make the.
So start there,
radius.
and then
Click on one of the
One of
vertices of the triangle.
one of the vertices of the triangle.
That as a radius.
Okay. Nice.
That's so,
That is cool. There we go. We got it. Nice job. Nicely done. Nicely done. Thanks for that discussion. And again,
if you,
we know it works if we can change the givens, right? Move around the triangle and still have, right, the construction hold true. All right. Any questions? Lena?